A diameter of up to 200,000 light-years, an intrinsic mass of 1.5 trillion solar masses, and possibly more than 400 billion stars. The dimensions of our home galaxy, the Milky Way, are truly difficult to comprehend. To understand how gigantic the barred spiral galaxy is in detail, it's advisable to imagine our cosmic home as a terrestrial snowdrift in the corresponding area, which in this thought experiment has an average height of just over half a mile and a diameter of 6 miles. Each snowflake, of which there are 3 per 35 cubic feet, symbolizes a full-grown star. If we were to include our sun, which generally appears to us as a colossal celestial object, in this metaphor, our host star would not even be as large as a microscopic virus. In view of these enormous dimensions, it's not surprising that we are still far from having deciphered all the secrets of our home galaxy. However, in today's video, we'll show you which mysteries of the Milky Way have already been revealed and which great puzzles experts are currently facing. Excited about the breathtaking discoveries and impressive phenomena in the cosmos? Then don't forget to subscribe to TheSimplySpace and click on the bell to join us on our journey to the greatest mysteries of the universe. By giving us a thumbs up, you'll be showing us that we can keep you engaged with the content of our videos. An enigmatic barrier. The question of what undiscovered secrets are hiding in the heart of the Milky Way has kept terrestrial researchers on tenterhooks for many decades. With every new discovery we make in the center of our home galaxy, we add another significant piece of the mosaic to the galactic picture. The bizarre structures that are sometimes hidden in this exciting central region are also shown in a study that was recently published by a team of Chinese researchers. As part of their work, the experts examined radioactive gamma rays. This is a particularly penetrating form of electromagnetic radiation that is produced during spontaneous transformations of atomic nuclei of radioactive nuclides. This is the case, among other things, when cosmic rays strike ordinary matter. In the course of their investigations, the Chinese scientists finally realized that something exists in the central region of the Milky Way that accelerates particles to rapid speeds. This phenomenon generates a veritable abundance of cosmic rays and gamma rays in the central regions of the Milky Way. There is, however, one particularly puzzling and striking circumstance. While these constant storms of high-energy radiation originating in the heart of our home galaxy reach space, something also exists there that is preventing the majority of the cosmic radiation from other parts of the universe from penetrating. In other words, it seems that there is an ominous barrier around the center of the Milky Way that keeps the density of cosmic rays there much lower than in the other regions of our galactic home. How exactly this invisible galactic shield works, or why it exists at all, is currently one of the biggest research questions facing scientists. But the mystery of what acts as a kind of cosmic particle accelerator within the central region also keeps experts in suspense. As a possible source of this puzzling phenomenon, one candidate in particular has moved to the center of scientific conjecture: Sagittarius A star, a gravity monster in the galactic center. At present, astronomers assume that practically every galactic center is graced by a supermassive black hole, and our Milky Way is no exception. In this case, the gigantic gravity monster has been christened Sagittarius A star, with an intrinsic mass of about 4.3 million solar masses. However, since black holes are typically characterized by their masses being concentrated in extremely small volumes, the event horizon of Sagittarius A star amounts to only 13 million miles. As is well known, such astronomical objects are also known to generate incomparably strong gravitational forces due to their compactness. Consequently, no radiation, no information, and especially no matter can cross the event horizon of a black hole from the inside to the outside. For some time now, experts have suspected that Sagittarius A star in the heart of the Milky Way could accelerate electrons and neutrons to near the speed of light. This in turn would generate cosmic rays that would then travel through our galaxy and into intergalactic space. During their journey through the gigantic expanses of space, the corresponding rays spread out via magnetic fields, forming a galactic sea of high-energy particles whose density remains roughly constant throughout our home galaxy. An unsolved puzzle. As part of their studies, the Chinese researchers compared the density of this cosmic ray C with the density of the radiation that prevails in the central region of the Milky Way. With the help of the information provided by the Fermi Large Area Telescope, scientists finally realized that a mysterious structure in the heart of the Milky Way actually functions as a huge natural particle accelerator and consequently emits enormous amounts of cosmic radiation into the other regions of the barred spiral galaxy. In theory, supermassive black holes like Sagittarius A star can also shoot certain particles into the cosmos while simultaneously engulfing all other forms of information that cross their path. With respect to the identity of the galactic particle accelerator, therefore, a possible candidate already exists in Sagittarius A star. However, researchers are still largely in the dark about the mysterious barrier that keeps the density of cosmic rays in the center of the Milky Way so low. The first vague conjectures say that the phenomenon could be connected with the confusing jumble of magnetic fields in the vicinity of the galaxy core. So it's theoretically conceivable that dense gas and dust clouds collapse and compress the magnetic fields. In this way, a natural shield could be created which would shield the areas behind it from the incoming cosmic radiation. Another theory suggests that it's the stellar winds of the countless stars in the heart of the Milky Way that push against the sea of cosmic rays, thus reducing their intensity. What is certain, however, is that further investigation is essential to unravel this great mystery. Violent spectacles. The exciting phenomena that take place in the central region of the Milky Way, more precisely in the areas around Sagittarius A star, can be seen, among other things, in an observation that was recorded for the first time in 2005. At that time, experts identified a gaseous object in the vicinity of the supermassive black hole, which they christened G1. 6 years later, another representative was to join the ranks of G objects. Scientists recognized that the gas cloud G2, which had 3 times the mass of our blue home planet, was heading directly towards Sagittarius A star. In 2013, parts of the cloud came within 15 billion miles of the gravity monster, whereupon the cloud was literally pulled apart by the black hole's elemental gravitational forces and brightly illuminated by the ultraviolet radiation of nearby stars. So far, a total of 6 of these mysterious G objects have been located in the center of the Milky Way. Their average size is about 100 astronomical units, which is 100 times the average distance between the Earth and the Sun. A look at the so far documented characteristics of the G objects shows that there are still many open questions to be answered. On the one hand, these astronomical formations show the typical characteristics of dust and gas clouds, while at the same time they exhibit dynamic behavior patterns, which we actually know from stars. What these objects are in detail is still uncertain. One explanatory theory is that the G objects are actually binary star systems that have begun to merge through the action of Sagittarius A star. The companions of Sagittarius A star. It became clear a good 15 years ago that the supermassive black hole at the center of the Milky Way enjoys the company of countless other mass monsters. At that time, with the help of the Chandra X-ray Observatory, conspicuous outbursts of brightness were registered in the regions around Sagittarius A star. In the course of a detailed investigation, experts finally came to the conclusion that there are up to 20,000 other black holes within a radius of about 70 light-years around Sagittarius A star, for which the central gravitational monster serves as a cosmic fixed point. If you like, these galactic companions also fulfill the purpose of constantly supplying Sagittarius A star with raw materials. Thus, the smaller black holes rotating around the central black hole accumulate clusters of stars around them through their gravitational forces. The clusters of glittering bright celestial bodies are consequently held captive by the black holes until the spiral orbits bring them into the immediate vicinity of Sagittarius A star. The extreme tidal forces that naturally exist in these regions in turn lead to the disintegration of the star clusters. As a result of this process, some stars also enter the sphere of influence of the central black hole, where they're finally swallowed up by the colossal structure. Presumably, this is not the only cosmic feeding process, in the context of which Sagittarius A star is constantly supplied with new matter. Other theories say that a gigantic ring-shaped gas cloud rotates around the black hole, whereby this becomes heavier and heavier in the course of time before it finally exceeds a critical mass. As a result, the gas cloud collapses and falls into the central region of our home galaxy, and thus directly into the voracious maw of the central black hole. Your opinion interests us. What do you think about those great mysteries hiding at the heart of the Milky Way? We're already curious about your comments. Finally, take a look at the other exciting videos on our channel, which you can access by clicking on one of the images in the credits. Thanks for your interest, take care, and we'll see you next time.